Hello YouTubers, welcome to my messy shop. We have finally got the MacGyver 2000 mill restored after the North Carolina flood. We have upgraded it to the MacGyver 3000. This mill has gone through a lot of changes. It was originally my lathe. It was my third lathe that I built, and the first two lathes I built were really stupid and they sucked and they didn't work at all. So we upgraded and I found a bigger spindle, and I had this pulley. I didn't have these gears and all that stuff. It was just my third lathe that I had built. Well, then I acquired my South Bend lathe, so I no longer needed this to be a lathe, but I needed a mill. So I took the whole spindle up, mounted it, and did a lot of work on it throughout the years. I built this mill about 6 years ago. It started at the metal recycle. Asheville, North Carolina has an awesome metal recycle center, and all these parts came from the metal recycle. Everything except for this 3-jaw chuck, I ordered that online from China. And since the flood, I have upgraded the motor to a nice brand new one. So I guess I'll start with the spindle. I just got it trimmed, and I have a way to adjust the trim on this, and that is with this doodad over here. And it's got bolts that push against this, I guess you'd call it a bushing, an aluminum bushing. It's got a slot in the cut in it so it can, grab onto this lead screw. And this is not threaded, it's just kind of sliding up and down on that. This part is threaded. This is the bearing on the bottom. I got a dust cover over it. Back to the spindle. I acquired this spindle. It's got steps in it, so it starts off at one diameter. It steps up to another diameter here. And I was able to find a bearing for this end, but I couldn't find a bearing for this end. It was an odd size. So I decided to pour one out of aluminum. This is the upgraded bearing. I just upgraded this a few weeks ago. The other one looked like total dog crap. It was a lost foam casting, and I had done that bearing before any of this was built, so I wasn't able to machine it right. I have an oil journal right here. I can drizzle oil in, and it goes in about right here and allows it to drizzle along the full length of the bearing. And then down here, I don't know if you can see it, but there's a step in this bearing to act as the thrust bearing. So all this is pushing up against that shoulder there. And I have a preload adjustment on this end. So I have a slot in here and this brass key, and this bolt right here, as I turn it down, it pulls the shaft up for a little bit of preload on this thrust bearing. And then I can lock it. This is a lock and nut right there. Pretty cool. I got this pulley to fit with it's a Browning style bushing. It's a pressure bushing. It's tapered. And as you draw these bolts go into this threaded hole on this pulley, and it pulls the pulley on. I don't use the pulley now to drive the spindle. It's more of, I just keep it there as a flywheel, and it makes the spindle more stable. The spindle is, however, driven by this flat belt. And there's an idler pulley right here And that keeps the belt where I want it. And it goes back to a drive shaft back there, which I'm going to show you here in just a minute. And this spindle has two ranges, like on a drill press. Well, drill press has more than two, but this is the same idea. I can move the belt down here and I get a slower range and more torque. At the end of the spindle, I have a chunk of aluminum, and what I did is I poured the aluminum around this shaft, and then I was able to machine it true. The cool thing about this is it's basically pressure fit, and there are a couple bolts in the end of this shaft, and so I poured this aluminum around the bolts and everything, and as it cooled, obviously it shrinks, and it made a really good grab on there that doesn't move at all. So this whole head just moves out like this. It's got this stiff arm, and that's what locks it in place to keep it from moving. I'm going to take you around back. Oh, the lighting is stupid. Hold on, I gotta fix the lights. Alright, we're going to try this again. See, I was having problems with my mill spinning too fast, and I couldn't cut like cast iron and steel, stainless steel. It was just burning up, you know, my cutters, my tools. So anyways, I had to gear this thing down, and I wanted multiple gears. So with this method, I have 3 speeds here, and then on the output shaft, this is the belt that goes to the spindle. There's a step, and I can move the belt to a different range. So I have essentially 6 speeds. So the motor is coming to this primary shaft. It's got a bearing at each end. There's a thrust bearing next to this main bearing. These gears are paired together. These are paired together. This set free spins, actually both these sets free spin. And there's a primary gear down here, and it is attached to the shaft. It does not free spin. These gears just free spin on this shaft. This shaft does not turn. It's just locked in place. And it transfers the load to this gear, which is sandwiched with this smaller gear. Those act as one. The load goes over to here, which is not free spinning, but it is locked to this pair. And then this pair transfers the load to this pair, and it keeps going. These are 2-inch gears to a 4-inch gear, so we get a 2-to-1 gear reduction each time we transfer to a gear. On the output shaft, this gear is allowed to slide up and down, although it is locked in to this shaft with this key here. Well, it's kind of bound up, but the idea is this is 3rd gear. It's the fastest speed. It's more of a direct route right to the motor. And then as I slide this up and I move my pin, this gear can catch 2nd gear, and then 1st gear is up here, which is the slowest one. You can see up here is a gear that I shredded a long time ago. I don't need it anymore, so you know I can move these gears around to put them wherever I want, right? So I have this Acme thread. I think it's like 2 3/4 inches. Pretty beefy. It's got a big old brass nut. Raise it up and down is a little rough. I have to stand on a bucket and climb up there and crank that up and down. So it's not the best method for raising and lowering this, but it does work. It's not something I have to do a lot of. Generally, once I set something at a certain height, it's just going to stay there. This mill table was a great score. When I seen it laying in the junk pile, I knew I had to have it right away. And I didn't have a mill or anything built at the time, but I just bought this just because. I think I paid like $17 for it or something. So I'm using all thread as a way to move the table. Although it works, it's pretty slow. It's not as fast as an Acme thread. I like this wheel. It came off of a water gate valve. Again, I'm using the all thread. And for ways, I used angle iron. I did have to clean it up. The angle iron, the skids that this all rides on, because the inside corner is rounded, I had to go in and sharpen that out and make it more of a sharp 90. And I just did a spot weld on these because I didn't want to heat it and warp everything, so the skids are not necessarily welded all the way across. So I have the tram set on this and everything's locked down. I've been over this thing 3 or 4 times. I've actually started it and run it, but I haven't cut anything with it. I have this piece of cast iron I want to try. And I think I just want to try to make it squarish. Take these rough edges off. You can see where I cut this with a grinder, a cut-off wheel, and then I snapped the rest of it off. I have a couple of fly cutters. I made these 2 fly cutters. And then this is more of a boring bar. It has an adjuster here, old school. And then I made this one out of a one of those barbells. And I made this one as well. Obviously they got flooded, was under a lot of mud. I was able to fish them out and hose them off, and that's where we're at with these. So I just got some gasoline and we'll scrub these and clean them up really good. And we're gonna, I think I want to try this fly cutter on this piece of cast iron, and let's see what happens. Alright, this fly cutter cleaned up pretty good. You'd be surprised at what you can do with some gasoline and a wire wheel. You know, people might think that flood mud is like the kind of mud that you play with when you're a kid. No, flood mud is full of diesel fuel, battery acid, antifreeze, motor oil, dog shit. So cleaning it is a real mofo. It is not easy at all to get it off your metal. And then when it starts rusting, obviously it just becomes a dog shit cake. Okay, we have the fly cutter installed. I know this Irwin machinist vise is awesome, and you guys are probably laughing your ass off at this, but I promise I have plans to make a real machinist vise. I just haven't found the right metal stock to do it with yet. I have my Chevy leaf springs for hold down clamps. They work pretty darn good. Some 3/4 inch bolts. They fit in them slots just right. I'm all set up to do a pass. Now I did cheat I just grazed that corner off right there off camera, and of course I got a little excited and forgot to turn the camera on and yada yada. Here we are. I'm doing the first probably actual level pass. We'll see what happens, and you folks can check this out. I am doing the second gear on my gearbox. Third gear is definitely a little fast for cast iron, so I dropped it down to second gear. I don't have a switch yet, so I'm just doing, I have this cord straight into the motor. Check your headphones, because this is going to be loud. Alright, it's cutting pretty darn good. I think I'm using the wrong tool for this job for sure. It's taking forever. I think the fly cutter is more of a finish tool. It's not so good at removing material, which is what I'm trying to do here. So I'm going to switch to an end mill. So I have this stubby end mill here. I think this is about 3/4 inches diameter. If you don't know this, end mills do not like to hold in a 3-jaw chuck very well. It will definitely come loose. It's just too hard and the chuck can't grab it. So I've made this, I guess you call it a collet to put this in. Let's give this a try. Now, my speed is probably too slow. I might have to go into third gear for this. Let's try it in second gear and see how it does. Well, the end mill would work pretty good, except I sharpened this end mill and it works like crap. So the thing is, instead of digging in and cutting, it starts skating on top of the part, and it's not like, you know what I'm saying, just digging in and cutting that out real well. It is cutting it, but it's skating hard. So I've got smaller end mills that are brand new. We could throw one of them in there, but I think the biggest I have is 12 millimeter. Besides that, the mill is working really well. I need to check all the bolts and everything and make sure nothing's vibrating out. And I'm pretty darn happy with the way it's running. It's not fast, I'll tell you that. It didn't cost much. This is an operation I could do on the lathe if I really wanted to. Put this in the 4-jaw chuck, and at least I would have, you know, an automated feed that could do that instead of me standing here turning this knob. I want automated feed on this eventually. It's not a big priority at the moment. There's lots of other things to do on the farm here first. Of all the tools that I own in my shop, I think this is my favorite. I'm older. I hate lifting stuff. And coincidentally, when the flood happened and I was moving all my stuff out of my shop in the mud, there was this I-beam laying in front of my shop. And later on, I went to Harbor Freight and got this stuff, this trolley, and this hoist. and it runs all the way down the center of my shop and out the door. It's really just nice to be out of the flood scare finally. It's been over a year and I'm still cleaning and restoring machines and such. There's the feed gearbox for my 1926 South Bend lathe. I still got to clean that out and restore it. But there are a couple of gears that I need to rebuild on that gearbox. And I really needed this mill to be going so I can cut gears. That's essentially why I built this mill anyways, for gear cutting. Not really for planing stuff, although I can plane stuff. It's not what I made this for. So this is a big celebration. I'm really happy that this thing is up and running. It's got some paint on it. When the weather gets nicer, I'll finish painting the welded areas and such. I'm going to call it good for now. I think this calls for a celebration. Peace out.